Hello everyone, welcome back to another video. So in this video, I'm going to talk about external secrets operator and its implementation with Vault in Kubernetes cluster. So for the demo purpose, I'm going to run external secrets operator along with Vault in my local machine, especially in the Minikube. And I have one interesting section about frequently asked questions also, so which we will cover that. So when you are installing the external secrets operator in your cluster, so that will be like couple of frequently asked questions about the architectural design and how it's going to work. So it's an interesting section which I'm going to discuss about that also. So let's get into that. So before actually getting into the external sequence operator, I would like to talk a little bit about the existing Kubernetes secret challenges. Okay. So when you're a person working in Kubernetes cluster, so Kubernetes has got like a lot of Kubernetes objects. So one among that is Kubernetes secret. Okay. So when you talk about Kubernetes secret, so Kubernetes secret manage all the secrets which will be like injected into the application later, right? So basically it manages all the sensitive information. So the information inside the Kubernetes secret is normally maintained not in encrypted state but in encoded state. So basically it is stored as base64 encoded, so you can easily like decode it because it's not encrypted. Okay, and another challenge is like how do you basically create a Kubernetes secret? So you will have like some YAML manifest, and then like using kubectl like manually like, you will execute that to create the Kubernetes secret. Okay, so when you're having the pipeline setup and then your version control system. Basically, like you have your Kubernetes manifest, Kubernetes secret manifest file in your version control system, and through the pipeline on the fly, you'll be injecting all the sensitive information, probably from the vault, or whichever secret provider have, or in the pipe through the pipeline itself. So on the fly, you inject that, and then like you deploy into your cluster. So that is again a challenge. Okay, so securely injecting um, uh, the secrets into your Kubernetes secret and into your cluster is a major challenge. Okay, and then like there is no mechanism to sync and update secret. So the first time you deploy your Kubernetes secret, and what if there is an update to the Kubernetes secret? So like you don't have like version controlling system for your secret, and to update secret, it's a challenge basically. So these are challenges which can overcome using the external secret operator. Okay. So let's get into the external secrets operator. So a little bit about external secrets operator. So it's an open source and it's a Kubernetes operator going to be installed inside a Kubernetes cluster, going to run inside a Kubernetes cluster. So the operator which is going to interact with your external secret provider. So external secret provider, when I say, so it's like HashiCorp Vault, Azure Key Vault, AWS Secret Manager, basically your application or any sensitive information like you maintain outside, like external secret provider. So when you're working in cloud, for example, when you're working in Azure, so you have your Azure Key Vault and AWS like, have Secret Manager and all the external secret providers. So these are called like external secret provider. So the external secret operator going to run inside of a Kubernetes cluster, which is going to connect to the external secret provider and going to fetch the secrets from there. And then it is going to create that as a that is going to be created as a Kubernetes secret. So that is where like the external secret is addressing the challenges of what we have seen in the previous slide. So the versioning will be taken care, the syncing and the reconciling, all these things will be taken care, and the update will be like will happen like automatically. So if there is an update, there is no need to run the pipeline from the very beginning and on the fly. You don't need to inject, so it's going to happen automatically. And like external secret operator uses like few of the custom resource APIs, like custom resources, CRDs we call in Kubernetes. So using that, makes the authentication and then like fetching the secrets from the external secrets provider possible. So we'll look at what are the APIs it is going to use. So on the high level, if I say these are the three APIs, the operator is going to use. So first, we are going to install the operator, and then like there will be like two of the three APIs will be used to make the authentication, and then like fetching the secrets from the external secret provider. Uh, it's going to be possible. The first cluster secret store, the cluster secret store and secret store is both are for the authentication purpose. So authentication to your external secret provider, and then what is the difference? The cluster secret store, it's going to make the authentication possible cluster wide. Okay. The secret store, it's kind of a namespace, right? If I have to compare that with other Kubernetes objects, it's like cluster role binding and then role binding. Cluster role binding, it's for defining a role for the entire cluster. Role binding is kind of a namespace level, right? So entire cluster can make use of this cluster secret store to connect to the external secret provider to manage your secrets. Okay. And then the external secret. So once the authentication made possible using either cluster secret store or secret store, then the external secret is the CRD where we define what are the secrets which we are interested to fetch basically from our secret provider. Okay. So on the high level, this is what I will show you during implementation. I will show you in detail like how this PRD is going to look like, and then like you will understand it clearly. Okay. So in terms of architecture, okay. Um, so consider this is a Kubernetes cluster, okay, and we are going to install external secrets operator using Helm, and there is like a couple of ways like you so assume that it is installed. So what it is going to do? So as I said, there is a custom resource, right? External secret. So this is the place we keep we list down all the secrets which we are interested to fetch. Okay, and behind the scene there is going to be like cluster secret store. Okay, so what happens when we define the list of secrets which we want to fetch from the external secret provider? So first, external secret operator watches that and takes down the information on the list of secrets, and then like behind the scene using the cluster secret store it authenticates to the vault, and then external secrets operator fetches the secrets basically from the vault. So here in our case for the demo purpose we are going to use HashiCorp Vault only. Okay, and then using that secret it is going to create the Kubernetes secret. So if you look at it on the very high level, so we are not going to maintain any Kubernetes manifest file at all. So we are going to maintain only external secret file only, and the external secret operator going to create Kubernetes secret naturally using the secrets which we have listed in the external secret. Okay. So this is about the architecture basically. So your operator along with the external secret API and then the cluster secret store API. First, authentication, does authentication to the secret provider. It can be Vault, it can be Azure Key Vault, it can be a secret manager, and then then fetches the secret and creates that as a Kubernetes secret. Okay. And the last slide is frequently asked questions. Let me come to that once we have completed the implementation and see the demo. I would like to show you some of the documentations I have. So this is my repo, like some README file which you can go through. So this is how you can install external secrets operator. So this is official page of the external secrets operator, externalsecrets.io. You can go there and you can read for yourself. So what it is about, and you can see external secret operator with custom resources. So yeah, you can go through this, and so this is what I know I was talking about, the secret store, um, and how it is going to communicate to the AWS secret manager. That is going to be your external secret provider, and how it's going to communicate using access ID and secret ID. So this is the official page. You can look for yourself. So if you look at this section, so in terms of installation, you can go to the getting started and you have the instructions on how to install. So the same I have given here. So in terms of Vault setups, as I said that I'm going to use Vault as my external secret provider, and I have Minikube running in my local. In the Minikube, I'm going to install both external secret operator as well as the Vault. Both is going to be running from a Minikube. So if you're interested to set up Vault in Minikube, you can look for this URL. And I'm not going to and I'm not going to show you like how to set up Vault in Minikube. And yeah, so this is one example of cluster secret store CRD. Now I was talking about. So first we need to install the external secrets operator, and then two APIs I was talking about. The one is cluster secret store. If you look at this for the external secret provider, we are going to use Vault. So there is a provider section under spec. So we are going to use Vault. Okay. So here the server section, we're going to define the vault endpoint. So in my case, it's running in my Minikube in local, so I have defined my endpoint. So in your case, for example, if you're working in a larger organization, the vault is going to be a centralized team, and there are going to be like multiple application or project team going to be a consumer of that, right? So your application or project might be running in one network space, and then your vault might be running in another network space. So you have to make that network connection possible. So all these things you need to take care. If it is running in the same network, then that is good. But whatever the case, you need to mention your vault endpoint here. Okay. And then so using so this vault, and then so if you know, if you're working in HashiCorp Vault, there is like version 1 and version 2. So here in my case, like I'm using version 2. And then how I'm going to do authentication to the vault. Okay, since I'm going to use vault, there are like multiple ways like I can authenticate to the vault. So one is like token based, one is app role based, and there is like OIDC based. So in my case, for the simplification purpose, I'm going to use token. Okay. So authentication using token. So that token I have created as a secret, and I'm referencing that secret. Okay. So if you see this using Flusher Secret Store, we are going to authenticate to this vault. Okay. And then once the authentication is done, we have so this is for the vault. If you are using, if you are going to authenticate to the vault using token, and this is another example, like if you are going to authenticate to the vault using app role. Okay, the same auth section, but instead of the auth token, we are going to use the app role. So if you are creating app role in the vault, you'll be getting a role ID and secret ID. Okay, so this is what I have given example. So for example, if you are going to instead of Vault, if AWS Secret Manager is going to be your external secret provider. So how do you authenticate? So in the provider section, you're going to mention AWS, and then like you're going to authenticate using the secret ID, and then and the access ID. Okay. So now using this first step, the to make the authentication possible. Second step, there is like another file. So this is a cluster secret. So for our demo, I'm going to authenticate to the Vault using the token. So that's what the first file. First CRT or first API file. And the second one is we're going to list down all the secrets which you want to fetch from the vault. So there is a kind of external secret we are going to use. This is the name of the external secret. And then there is a target section. Okay. This is the target section. As I said, we are going to use external secret, and this is going to create the Kubernetes secret on its own. Okay. So this is the name of the Kubernetes secret it's going to create. Okay. And then the data section. So when your Kubernetes secret gets created with this name, ASO open secret, and this is going to be the data block. So inside the data block, there are like two key value pairs we are going to be part of the data block. Okay, so one is username and another is password. So inside the data block, this is the key username, and the value is going to be fetched from this is a secret path in the vault. Okay, so I have a vault running already, and I have this path kv/cred, and inside that path I have like username and then the password. So which I'm going to fetch. Okay, so this is my vault. So running in my local, and then like I have port forwarded and this bot. Okay, so I have a path kv and then the secret, and I have a password username. Okay, so initially my password value is like 789. So this is what I have here. Okay. So username and password we are going to fetch from the vault. So we have to authenticate, right? So we have already created the cluster secrets for the API. So using this, it's going to authenticate and it's going to fetch the information from the secrets from the vault. So hope you have got it. Okay. So let's get into the implementation part. So at the moment, like I have done installation of the external secrets operator and Vault also. So both are running in my local. So this is my Minikube cluster. I will show you like so both are installed in my external secrets namespace. Okay. So at the moment that external secrets related operator stuffs are running, and then in the Vault I have like Vault is running. Okay. So the Vault is running. So I have port forwarder and it is running in my local, okay, from the browser. So now what I'm going to do, I have these files, okay, the cluster secret store and external secret file. So the same, the what I've shown from the report, the same is defined in my file, okay, the cluster secret store. authenticate to the vault using this token, and then the secrets I have listed in my external secret API that is going to be created as a Kubernetes secret. Okay. So if you want to look at it, like a secret store. So this is a token and stuff, and this is already. So we are going to run both the files. Okay. So in external secret. Yeah. So these two are the secrets which I'm interested to create. Okay. So now I'm going to run uh, cluster secret. Okay. So it's created. You can see the CRD. Okay, so there is a secret store got created. So how can you validate whether it got created correctly or not? You can see the ready state is true, and you can describe this and see for more information. So if you look at this, so this is the endpoint I'm using. So the Vault service, which is running in my local. So this is the endpoint. And if you see, so how can you validate? So there should be a message saying that store is validated, which means the authentication to the Vault is positive. Okay, and you can see the store valid. Otherwise, you'll be seeing a false message here in terms of ready state. Okay, so which means the cluster secret store is successful. Let's deploy the so, and then like we have created a Kubernetes secret also, right? Uh, where we are keeping the token. So, okay, so there is a vault token secret which is used here, cluster secret store, and does the authentication. Okay, so now we run election secrets. Okay, and we can check using this secret and secret namespace. Okay, you can see external secret of name sample external secret got created and it's using the secret store vault secret store. So this is the one it's using for the authentication. And you can see the status is secret sync and ready is true. So if it is not able to fetch the secret, what you have defined in your external secret, from the vault, the state will be true and that there will be like secret sync, there will be false. Okay, there will be some error, secret sync is error is false. So now external secret created. Let's see like whether the secret Kubernetes secret got created. Okay, so you can see the Kubernetes secret got created. So this is the name we have given, right? So okay, if you see here, this is the Kubernetes secret name we want, and inside that we want like username and password. Okay, so we'll get it. Yes, so I can secret and then secrets. And then, okay. So if we see here, so we have like password and we have like username. Okay. So for example, let's try to decode this. Okay. Uh, yeah. So the password is like 789. So that's what we have seen here, right, in the vault actually. So in the FAQs, we will see that, if I change the password, how soon, like how quickly it is able to like reconcile or try to fetch that information and update that. Okay. Um, so now you can see that by deploying the external secret CRD, where we list on all the secrets, so it creates a Kubernetes secret, automatically. Okay. So that's the implementation. Um, Let me go back to the FAQ section. So that's an interesting section. So why I'm going to talk about the FAQ is something that when I try to implement the external security operator in my organization, there are like a lot of architectural related questions came from the management, and I wanted to address that actually. So that's why thought of passing that information. So important question. Okay. So what happens when your secret management provider got into outage? So in our case, we are going to use Vault as Vault. We are using Vault as our external secret provider. Right? So what happens? if that itself, got into outage. So which means you have this file, okay? You have this cluster secret store file, which does the authentication to the vault, right? If the vault itself, gets into outage, so what will happen? So you have, so the cluster secret store, right? So the status is going to be false, which means the authentication is not going to happen. And then the created Kubernetes secret, it is going to be available. It's not going to be deleted. But if there is any update to that secret, that is not going to happen until or unless the vault comes into live. Then only the Kubernetes secret update can happen. Okay. The second question, how quick my secret gets synchronized? Okay. So for example, we have our version one of our secret, okay, in our vault, for example. So like if I'm updating my secret into the vault, my version two, okay. So how quickly like my Kubernetes secret inside my cluster gets updated? So that's what's the question, okay. So if you observe the external secret CRD, there is a refresh interval, okay. Here you can mention in seconds or minutes or hours also. So it's going to recheck again. Okay. Periodically, it's going to check every 10 seconds. It's going to check from the vault whether the secret, there are any new versions or any update has happened. Okay. If there's an update, it's going to fetch within 10 seconds. It's going to update it. Okay. So we'll show that in live. So if you see the password is like 789. Okay. So I'm going to change this. Okay. So let's change this to like 123 and see whether it is getting updated like within 10 seconds. Okay, so now I've done that. See our keyword secret. Okay, so you can see this. I think the password is changed. So if we decode it, you can see the password 123. So that is how it gets synchronized, fastly. So it's based on your refresh interval. If you do not want in seconds, you can always keep in minutes. So for the demo purpose, I wanted to show how quickly it gets synchronized. That's why I kept it in seconds. But in reality, we keep in a few minutes actually. Okay. The third question, um, what happens when secret in vault gets deleted? Okay, that's a very valid question, right? So you are relying on external secret provider for the secret. What if that secret gets deleted? Okay. If the secret gets deleted, uh, you're going to get error here. For example, in the external secret, so sorry. So here, the secret synced, it's going to be like false. Okay. So this is going to be like false. Okay. So it's going to show like some error. Okay. But whatever the Kubernetes secret you have created, that's going to be available. But this is going to be like false. Okay. It's no more able to will be able to connect to the vault, will not be able to fetch that secret. Okay. So, and then the fourth question, what happens when external secret gets deleted? So we have this file, right? So using this, so we have this file and using this only, we have created the external secret CRD and then which automatically creates the Kubernetes secret, created Kubernetes secret, right? So what happens if we delete that file? We delete this file, the Kubernetes secrets also going to get deleted because this is the file which controls and creates a Kubernetes secret object. Okay, and this if this gets deleted, the actual Kubernetes secret also going to get deleted. Okay, what if the Kubernetes secret is already available? This is also another question, right? So, for example, when you are not using external secret operator and when you have like already some Kubernetes secrets created in the same name, and then what you defined in the external secret object is also in the same name. What happens when I run the external secret? Okay. So whether it's going to throw error, whether it's going to say that it already exists, that's the question basically. So, and again, I want to show you in this file, there is a field, there is a feature called creation policy owner. So there are like three policies you can have, like creation policy owner is a default. There is like owner, create, and there is merge. Okay. The owner is something if you have already Kubernetes secret available and you are defining the same Kubernetes name. So this is the Kubernetes secret name you're defining, and that secret is already available. So what happens when you run? It is going to override that. Okay, so now the external secret operator, the external secret here is going to take ownership of the Kubernetes secret, and in future it's going to take care of the update also. So if it is not there, it is going to create. If it is already there, it is going to take ownership of it and update it. And there is a creation policy called create. So in that, what is going to happen? So again, if the Kubernetes secret is not there, it is going to create. If it is already there, it is going to throw error saying that the Kubernetes secret already exists with the same name, so it cannot be created. That is the second option. Third option is merge. Merge is something that again, the secret is not that it's going to create. If it is there, then it is going to merge that. For example, you have defined two key value pairs inside your Kubernetes secret data block, and the external secret operator, you have defined like two different key value pairs. Okay, so what it's going to do? It's going to merge it. So you're going to have like four key value pairs inside of your data block. So that is what going to happen. Okay, so I think that's all with this video. So hope you like this video. Um, Thank you very much. We'll see in another video. Thank you.